China launches CAP1400 reactor design, history, present and future. Introduction. On January 19, 2025, the State Power Investment Corporation SPIC of China celebrated a significant milestone in nuclear energy development with the official launch of the CAP1400 reactor design. This achievement marks a pivotal moment in China's journey toward nuclear energy independence and technological advancement, showcasing its commitment to expanding its footprint in the global nuclear market. Historical development of CAP1400. The CAP1400 reactor design represents an evolution of the AP1000 pressurized water reactor originally developed by Westinghouse. The project officially commenced on September 29, 2020, after over a decade of intensive research and development efforts. The design aimed to enhance safety, efficiency, and localization in manufacturing, thereby reducing dependency on foreign technology. 1. R&D phase. The genesis of the CAP1400 involved substantial groundwork characterized by rigorous testing and analysis. The preliminary safety analysis report received approval from China's Nuclear Regulatory Authority in September 2014. Following a comprehensive 17-month review. This approval was a critical step affirming the design's safety and viability. 2. Technological breakthroughs. SPIC's chief engineer Zhang Mingguang highlighted that the CAP1400's development overcame several technological barriers, achieving over 90% localization in essential components such as pumps, valves, pressure vessels, and control systems. This localization is projected to reduce project costs by approximately 20% once mass production commences. 3. Construction progress. The construction of 2 demonstration units is currently underway at the Huaneng Group's Shidaowan site in Shandong Province, with the design phase nearing completion at 99.2%. This development indicates the readiness of the CAP1400 to enter the operational phase, positioning it as a critical player in China's energy strategy. Current status and international aspirations. SPIC is actively promoting the CAP1400 design on the international stage, eyeing potential partnerships with countries such as Turkey and South Africa. The CAP1400's successful navigation through the International Atomic Energy Agency (IAEA's) safety review in May 2016 has bolstered its profile, making it more attractive for international collaborations. While the IAEA review does not provide clearance for specific projects, it assesses the safety documentation's quality, thereby facilitating compliance with country-specific standards. Comparative analysis, commonalities and divergences. Various reports emphasize the CAP1400's safety, technological independence, and market competitiveness. However, they differ in focus. Common themes. All sources agree on the CAP1400's potential for significant impact both domestically and internationally, highlighting its safety features and cost-effectiveness. Divergent focus. Reports from sources like World Nuclear News (WNN) emphasize technological advancements and economic advantages, while others such as NEI magazine highlight international collaboration and market outreach strategies. Future prospects. The future of the CAP1400 appears promising, with SPIC's plans to deploy this reactor design both domestically and internationally. The success of the CAP1400 is expected to bolster China's position in the global nuclear energy market, leveraging its technological advancements to capture a larger market share. Furthermore, the insights gained from the CAP1400 project's development will serve as a foundation for future nuclear energy initiatives, guiding China towards sustainable and efficient energy solutions. Conclusion. The launch of the CAP1400 reactor design signifies a crucial leap forward for China's nuclear energy sector. With its emphasis on safety, technological independence, and international collaboration, the CAP1400 is poised to play a critical role in meeting China's energy demands while contributing to global nuclear energy advancements. As SPIC continues to promote this innovative reactor design, the world will closely watch China's next steps in its nuclear energy journey. The CAP1400 reactor design represents a notable advancement in China's nuclear energy landscape, encapsulating a trajectory of innovation and strategic positioning within the global nuclear market. Here are several counterintuitive insights derived from the development and implications of the CAP1400 reactor. 1. Technological independence versus initial dependency. While the CAP1400 design is heralded for achieving over 90% localization in its critical components, it is counterintuitive to consider that this level of independence stemmed from an initial reliance on foreign technology, specifically that of Westinghouse's AP1000 reactor. The narrative often frames technological independence as a straightforward evolution. However, the reality involves complex transitions where initial dependencies catalyze domestic innovations and breakthroughs. 2. Safety as a competitive advantage. The emphasis on safety in the CAP1400 reactor design is presented as a competitive advantage in global markets. This may seem intuitive, but it contrasts sharply with the prevalent global perception of China's nuclear safety record, which has faced skepticism due to historical incidents and regulatory challenges. The successful passage of the IAEA's generic reactor safety review, while significant, does not erase these concerns but rather highlights a strategic pivot where improved safety protocols are marketed as a unique selling point. 3. Cost reduction through localization. The assertion that localization can lead to a 20% reduction in project costs after mass production runs counter to the common belief that advanced technology inherently comes with high costs. This positions the CAP1400 not just as a technological achievement but also as a model for cost-effective nuclear power generation, challenging the assumption that high-tech projects must always be expensive and reliant on international supply chains. 4. International market penetration. Despite domestic priorities, the CAP1400's international marketing push, particularly towards countries like Turkey and South Africa, appears paradoxical given China's ongoing domestic energy needs and expansion plans. The idea that China can effectively export nuclear technology while simultaneously meeting its energy demands suggests a level of confidence and capability that may not align with broader narratives of energy scarcity or reliance on foreign technologies. 5. Perception of nuclear energy. The promotion of CAP1400 in the context of global energy solutions may seem counterintuitive given the growing wave of skepticism and opposition to nuclear energy worldwide, especially in the aftermath of disasters like Fukushima. China's approach, positioning nuclear energy as a clean and viable alternative to fossil fuels amidst climate change discussions, challenges the narrative that public sentiment is universally against nuclear energy. This implies a potential reshaping of perceptions through strategic communication and evidence of safety improvements. 6. Regulatory approvals as milestones. The lengthy regulatory approval process for the CAP1400, particularly the 17 months taken for the preliminary safety analysis report, might intuitively suggest bureaucratic inefficiency. However, this thorough vetting process can be seen as a strategic advantage that enhances credibility and trust in the technology, potentially easing its acceptance in international markets where regulatory scrutiny is a critical factor for adoption. 7. Exporting technological innovation versus energy resources. The focus on exporting the CAP1400 design versus China's vast energy resources presents a counterintuitive strategic pivot. It emphasizes a shift from being seen primarily as a resource-rich nation to a leader in advanced technology and innovation in the nuclear sector, which may reshape global perceptions of China's role in energy provision. 8. Global cooperation amidst competition. The discussions of potential partnerships with countries like Turkey and South Africa reflect a nuanced understanding of global competition and cooperation. While it may seem counterintuitive for a rapidly advancing nuclear power like China to seek collaborations with countries that are developing their nuclear capabilities, this approach underscores a strategy of mutual benefit that could enhance China's influence and secure its position in the global energy market. In summary, the development and promotion of the CAP1400 reactor design encapsulate a series of counterintuitive dynamics that challenge conventional narratives about technological independence, safety, cost effectiveness, and global energy strategies. Each of these insights reveals the complexity behind China's nuclear ambitions and the strategic maneuvers that could redefine its role in the international energy landscape. The launch of China's CAP1400 reactor design represents a pivotal development in the country's nuclear energy sector, reflecting both historical advancements and future potential. While the overall narrative of the CAP1400 is significant, there are numerous details that may be overlooked by many observers, yet they are crucial for understanding the broader implications of this project. Here are some of the key overlooked aspects. 1. Technological autonomy and local manufacturing. One of the standout achievements of the CAP1400 design is its high localization rate of over 90%. This figure is not merely a statistic, it signifies a paradigm shift in China's approach to nuclear technology. By achieving technological autonomy, China is not only reducing dependency on foreign technology but also fostering its own industrial capabilities. This move can be seen as a strategic maneuver to enhance national security and economic independence, particularly in an era where geopolitical tensions can disrupt supply chains. The significance of this localization lies in its potential to stimulate domestic industries, create jobs, and improve technological capabilities. As China invests in local manufacturing, it can potentially lower costs and improve efficiency in the long term, making the CAP1400 more competitive in both domestic and international markets. 2. Regulatory milestones and safety standards. While the approval of the CAP1400 design by the Chinese nuclear regulator is frequently mentioned, the implications of passing the International Atomic Energy Agency (IAEA's) safety review in 2016 are often understated. This review is essential not just for compliance but also for establishing credibility in the global nuclear market. It reflects the design's alignment with international safety standards, which is critical for countries considering the adoption of the CAP1400. The safety review process highlights the rigorous scrutiny and validation that the reactor design underwent, reinforcing the notion that the CAP1400 is not only a domestic product but one that can meet stringent international safety requirements. This could pave the way for smoother negotiations with potential international partners. Reducing barriers to entry in foreign markets. 3. Economic implications of cost reduction. The projected 20% reduction in project costs due to mass production of the CAP1400 is a significant factor that may be overlooked. This reduction is not just about making the reactor more affordable, it has broader economic implications. Lower costs can make nuclear energy more competitive with other forms of energy such as coal, natural gas, and renewables, particularly in developing countries where energy needs are growing rapidly. Additionally, the cost savings can enhance the feasibility of nuclear projects in regions where financial constraints have previously limited development. This positions the CAP1400 as not just a technology for China but as a viable solution for countries aiming to expand their energy portfolios sustainably. 4. Strategic international partnerships. The discussions between SPIC and countries like Turkey and South Africa for potential collaborations are often treated as ancillary information. However, these partnerships are crucial for several reasons. First, they can facilitate knowledge transfer and collaborative innovation, enhancing the global competitiveness of the CAP1400. Second, establishing international partnerships can act as a diplomatic tool, strengthening China's influence in regions where these technologies are deployed. These collaborations also reflect a broader trend of increasing global interest in nuclear energy as countries seek to meet carbon reduction targets. The CAP1400 could thus serve as a bridge for China to engage more deeply in international energy politics, positioning it as a leader in nuclear technology. 5. Implications for future nuclear projects. The success of the CAP1400 project is likely to set a precedent for future nuclear energy projects in China and beyond. It can serve as a model for other nations looking to develop their own nuclear capabilities, particularly in terms of achieving localization and technological independence. Additionally, The lessons learned from the CAP1400's development could inform future reactor design's regulatory processes and safety protocols. Moreover, as China seeks to export its nuclear technology, the CAP1400 could become a flagship product that demonstrates China's commitment to safe and sustainable nuclear energy. This could lead to the establishment of a new standard in reactor design and operation, influencing global nuclear energy trends. 6. Impact on domestic energy landscape. While the CAP1400 is designed for export, it also has profound implications for China's domestic energy landscape. With China's commitment to reducing carbon emissions and transitioning to cleaner energy sources, the deployment of CAP1400 reactors can significantly contribute to meeting these environmental goals. The ability to produce large amounts of reliable and low-carbon electricity is essential for sustaining economic growth while addressing climate change. In addition, the CAP1400 can bolster energy security by diversifying China's energy mix. As the country grapples with energy demands and environmental challenges, the role of nuclear energy as a stable and low-emission source becomes increasingly critical. Conclusion. The launch of the CAP1400 reactor design is a significant milestone in China's nuclear energy journey, embodying technological innovation, economic strategy, and international collaboration. The overlooked elements, such as the focus on local manufacturing, the importance of regulatory approvals, the economic implications of cost reductions, and the strategic international partnerships, highlight the multifaceted impact of this development. Understanding these nuances offers a deeper appreciation of not only the CAP1400's potential as a reactor design but also its role in shaping the future of energy, economic policy, and international relations in the context of nuclear technology. As China moves forward with this project, the implications will likely resonate far beyond its borders, influencing global energy dynamics for years to come. 1. Technological autonomy and innovation. The CAP1400 reactor design signifies a major leap in China's nuclear capabilities, reflecting the country's commitment to achieving technological autonomy in nuclear power. By achieving over 90% localization of key components, such as pumps, valves, and pressure vessels, China has successfully broken previous technological monopolies held by foreign firms. This not only enhances national security but also reduces dependency on international suppliers, fostering a self-sustaining nuclear ecosystem that could potentially lead to lower costs and increased efficiency in nuclear energy production. 2. Safety and regulatory milestones. The rigorous safety evaluations and approvals from the Chinese Nuclear Regulatory Authority, as well as the successful passage of the International Atomic Energy Agency's IAEA Generic Reactor Safety Review, underscore the design's adherence to international safety standards. These milestones not only validate the safety and reliability of the CAP1400 but also position it favorably for international markets where safety is a paramount concern. The emphasis on safety is critical for public acceptance and regulatory approval both domestically and abroad. 3. Economic implications and cost reduction. The projected 20% reduction in project costs through mass production of the CAP1400 reflects significant economic implications for China's energy sector. This cost efficiency can make nuclear energy more competitive compared to other energy sources, especially in the context of global energy markets that are increasingly focused on sustainability and cost effectiveness. The ability to produce a large number of reactors economically could not only fulfill China's growing energy needs but also provide export opportunities, thus enhancing China's position in the global nuclear market. For international collaboration and market expansion, the strategic move by SPIC to promote the CAP1400 design internationally indicates a forward-looking approach to market expansion. Engaging in discussions with countries like Turkey and South Africa highlights the potential for international collaboration in nuclear technology. The emphasis on exporting the CAP1400 design not only serves as an economic opportunity for China but also positions it as a key player in the global nuclear landscape. This aspect of the CAP1400 project reflects broader geopolitical dynamics where nations seek to form partnerships in energy development, thereby enhancing energy security and technological exchange. 1. The Manhattan Project 1942 to 1946. The Manhattan Project was a secret U.S. government research project that developed the first nuclear weapons during World War II. It involved extensive scientific research and collaboration among various entities, including the Army Corps of Engineers, scientists from universities, and private industry. The project led to the creation of 2 nuclear bombs which were dropped on Hiroshima and Nagasaki in 1945, effectively ending the war. The project marked a significant advancement in nuclear technology and had profound implications for international relations and military strategy during the Cold War. 2. The Chernobyl Disaster 1986. The Chernobyl disaster was a catastrophic nuclear accident that occurred at the Chernobyl nuclear power plant in Ukraine, then part of the Soviet Union. A reactor explosion released large quantities of radioactive particles into the atmosphere, which spread over much of Europe. The disaster highlighted the risks associated with nuclear power and led to widespread changes in nuclear safety protocols and policies worldwide. It also sparked public concern about nuclear energy influencing future nuclear energy policies and the development of newer, safer reactor designs. 3. The Fukushima Daiichi nuclear disaster 2011, following a massive earthquake and tsunami. The Fukushima Daiichi nuclear power plant in Japan experienced a series of equipment failures that led to nuclear meltdowns. The disaster resulted in the release of radioactive materials and prompted the evacuation of thousands of residents. In the aftermath, Japan and other countries reassessed their nuclear energy policies and safety regulations. The event underscored the importance of safety measures in nuclear reactor design, leading to innovations in reactor technology and increased emphasis on disaster preparedness in the nuclear industry. Future outlook, predictions for the CAP1400 reactor design. The CAP1400 reactor design represents a significant advancement in China's nuclear energy capabilities. As it moves from development to deployment, several predictions can be made regarding its future impact on both domestic and international energy landscapes. 1. Increased domestic deployment. China's energy strategy emphasizes a transition towards cleaner energy sources, and nuclear power plays a crucial role in this vision. With the successful construction of demonstration units in Shadayawan, it is anticipated that the CAP1400 will see widespread adoption across Chinese provinces. By 2030, projections suggest that several additional CAP1400 units could be operational, contributing significantly to China's energy grid. 2. Cost reduction and economic benefits. The CAP1400's high localization rate of over 90% means that the majority of its components are manufactured domestically, significantly reducing costs. As mass production ramps up, the anticipated 20% cost reduction will enhance the economic viability of nuclear power in China. This could lead to a competitive pricing model compared to fossil fuels, especially as carbon pricing becomes more prevalent globally. 3. Global market penetration. With the successful completion of the IAEA's Generic Reactor Safety Review, the CAP1400 is poised for international marketing. Countries seeking to expand their energy portfolios may look towards CAP1400 as a reliable and economically feasible option. Partnerships with nations like Turkey and South Africa could pave the way for CAP1400 to become a preferred choice in regions experiencing energy shortages or transitioning from fossil fuels. 4. Technological leadership and innovation. The CAP1400's development has positioned China as a leader in nuclear technology. As the world grapples with climate change and energy security, the demand for advanced nuclear technologies will rise. China could leverage its experience with CAP1400 to lead in the development of next-generation reactors such as small modular reactors (SMRs) and advanced fast reactors. This may solidify China's role as a global innovator in nuclear energy. 5. Enhanced safety protocols. The CAP1400 design emphasizes safety, a critical concern for nuclear energy. As the reactor becomes operational, ongoing enhancements in safety protocols will likely be implemented. Not just for CAP1400 but for the nuclear industry at large. This proactive approach to safety could influence regulatory standards worldwide as other nations look to emulate successful safety measures. 6. Support for renewable integration. As the energy grid increasingly incorporates renewable sources, the CAP1400 could provide a stable baseload power supply that complements intermittent resources like solar and wind. This synergy may enhance grid reliability and promote a smoother transition to a low-carbon future. By 2040, it's expected that the CAP1400 will be part of an integrated energy strategy that balances nuclear and renewable energy sources effectively. 7. Nuclear diplomacy. The international collaboration stemming from CAP1400's development could lead to strengthened diplomatic ties between China and other nations. As China exports its nuclear technology, it may foster partnerships that extend beyond energy, influencing geopolitical relationships and trade agreements. This aspect of nuclear diplomacy may reframe China's role on the global stage, positioning it as a key player in energy security discussions. 8. Research and development initiatives. The success of the CAP1400 will likely catalyze increased investment in nuclear research and development within China. This could lead to innovations not only in reactor design but also in associated technologies such as waste management, decommissioning processes, and enhanced fuel cycles. By 2035, a robust R&D ecosystem may emerge, further enhancing China's nuclear capabilities and sustainability practices. Conclusion. The CAP1400 reactor design is set to play a transformative role in the future of nuclear energy in China and potentially beyond. As it integrates into the energy landscape, it promises not only to enhance energy security and economic competitiveness but also to position China as a leader in global nuclear technology. With the ongoing emphasis on safety, innovation, and international collaboration, the CAP1400 could fundamentally reshape the dynamics of energy production in the coming decades.